All right, we're going to talk about the last page of notes, which is association and causation with scatter plots. Okay. Now, association, aka correlation, right, is a relationship between two measurable variables. This is your correlation. Causation is a relationship between two measurable variables in which one directly causes change in the other. Again, mathematicians are really, really unique when it comes to naming things. Something causes something else to change. Hey, let's call it causation. Awesome. Okay? If something just relates to another, correlation. All right? Now, we're going to discuss the association and causation for the scenarios below, aka causation or correlation. A moderate association exists between the amount of ice cream sold and the number of shark attacks. If I sell here in Texas, in the Woodlands, ice cream, without being sarcastic, does that affect if I have more shark attacks in Galveston? No. So this is not a causation, this is a correlation. Where one does not directly affect the other, but we are comparing the two. One doesn't affect the other, but we're still comparing them. Okay? A strong correlation exists between the scores received on the final exam and the number of hours students spent studying for the exam. Again, without being sarcastic with y'all's remarks, if I study for a test, and the more intense and the longer I study for a test, the more prepared I could possibly be. Is that correct? Yes. Okay, hypothetically, yes, it is. Okay? Well, not all the time. If you cram, it's not. Okay? A strong correlation exists between the scores received on the final exam and the number of hours students spend studying for the exams. Okay? Now, here's the situation. Corbin, how hard did you study for the last test? Huh? Pretty hard, right? Okay. Did you get a good grade? Okay, so you really studied and you got a good grade. Daniel, how hard did you study?
Not too much.
Not too much. How was your grade? Was it pretty good?
All right.
So, I have someone who really studied hard and got a good grade, and I have someone who didn't really study that hard but still got a pretty good grade. So, do you think that if the longer I study guarantees a better grade? No. Okay. Could it? Yes, it could, but it probably can't. Because I can say one or the other, like it could or couldn't give me a guaranteed good grade. That's why this changes to a correlation. I have a rubber band on my fingers. I have ADD, so I fidget. Okay? So, again, because I can ask myself, okay, if I study for longer periods of time, does that guarantee a good test grade? If I can say yes, maybe no, it's a correlation. Okay? That's the correlation. All right. Scientists are studying the population of wolves and deer in one area of the forest. They found that as the populations of wolves increase, the population of deer decrease. Would that be a correlation or a causation? Causation. Okay, wolves eat meat. Okay, wolves are carnivores. Okay. The decrease in deer is a direct reflection of the increase in wolf population. Okay? That's how we get causation. All right? Now, a school did a study comparing students' shoe size to the reading levels. As students' shoe size is increased, the reading levels increased. Is this a causation or a correlation? AKA, am I just comparing two things, or does one actually affect the other? All right, Jackson, what size shoe do you wear? 14s. Okay, I wear a size 11. All right. How well do you read? Not well. Okay. How well do I read? Not that great, but probably better. Okay. All right. Maybe because I've had more schooling. Okay, and I've had more practice doing it. Does our shoe size mean that he's a better reader than I am? No. No. Okay, this is saying the bigger the shoe size, the better the reading level. He wears the 3 sizes bigger than I do. You didn't know 14? Okay. All right. Now, because shoe size has nothing to do with brain capacity, okay, this is a correlation. Did you say you have a first grade reading level? Was that what you just said? All right. So,